Let's learn how to register Raspberry Pi with AWS IoT Core. We will make Raspberry Pi to send data to AWS IoT service and then read the data from AWS to third-party MQTT client application like MQTTFx.
So once we log into our AWS account, we have to search on the top left corner IoT Core, and in AWS we have AWS IoT Core service, so we have to click on this. So since we are registering our Raspberry Pi as an IoT device into AWS IoT Core IoT platform, we have to first come to the AWS IoT platform. So when we click on AWS IoT Core, it will take us to this dashboard, and this is basically AWS IoT dashboard. You can see we have quite a few options into the left pan where we have MQTT test client, and we have all devices, green grass, remote actions, and much many things. We will see that in a future lesson, but today in this video lesson we have to register our Raspberry Pi into our AWS IoT Core. So we have to click on all devices, and under all devices we have this things, so we have to click on things and it will take us to some menus here. Okay, so you can see here on a dashboard we don't have anything. Thing means an IoT things, right? So Internet of Things refer our Raspberry Pi as a thing, say for example. So what we have here is this create things button. So when we click on create things in order to start registration of Raspberry Pi into AWS IoT Core, so click on create things, and then we get two options. Either we can register a single thing, so create single thing, or multiple or many things. We keep it as it is and we have to click on next, and then it asks us to give us a name. So because we are registering a Raspberry Pi as a device, we would keep it simple. We will keep it Raspberry as a thing name on our AWS IoT Core platform. And then when we scroll down a little bit, we can see thing type, which is an optional, but I would rather like to give the thing type to define a type. So I click on create thing type, and I would just give it a simple thing type as a Pi, and then click on create, and it will be created. It's basically an optional, but I always suggest people to do that because it's important. When you have too many devices into AWS IoT Core, then you can group them together on the top of the type that you have defined. So the type is really very important. So we specify the thing name as Raspberry and thing type as a Pi. We scroll down in lower right corner and there is a next button. We click on next, and then you say it asks us that it has to create a certificate. So it basically generates an auto certificate. So it auto generate a certificate for our device, that's our Raspberry Pi. So we are okay with that, so keep it as it is. Then just click on next on a lower right corner, and then you see there's an option which says policies. So we have to create a policies. Now if you wonder what is policy is an access policy. So if you want to give it access to this AWS thing to somebody else, you need to have a policy so that this person could able to access. So we have to click on, and it would take us to a new window, and basically here we have to define a policy. So policy name, I would rather keep it Raspberry because my thing is Raspberry, and so I would like to keep it simple and say Raspberry policy, and then scroll down. The policy effect will be allow. Policy action means what are the actions that you want this policy to have. I mean, what all the actions that this person who has this policy could able to perform. So in the drop down we have to select star, so it gives us all the permission: publish, subscribe, connect, disconnect to IoT server. So we will be okay with giving all the permission, so we grant basically all the actions. And then policy resource, here we have to put star, and star is basically considering the entire space where we store our data in the database. Right in the back end there is a SQL servers, so we better put it star here, and then click on create. So the policy will get created. You see the policy is created, and successfully created policy, Raspberry policy. Right now we go back to our IoT Core. You see now the policy was empty, it was 0 before, and since on the other tab we created a policy, we can able to see in the earlier tab now the policy shows up, and we have this lower right corner create thing button. So when we click on create things button, and then the things will get created, and you see we have the certificates to download. So we have this device certificate, then we have a public key, private key, and then we have a root CA file. So we will have to download device certificate. So I would click on this download button, and then we have a public and private key. So public key is something that you need when you want to publicly share the information, device data. So we can click on this download button, so it will download the public key, and then there's a private key, so we click on this download button, so that would basically download the private key as well. And root CA certificates we don't need, because if you want you can download it from here, but I have given in a GitHub link from where you can download universal root CA certificates, right? So that's all. We have to go to download section on our browser, and you see all this certificate files are here. So we will go to the download folder, grab all the 3 certificates, and we would cut this certificate. Okay, and then on a desktop I would like to create a fresh new folder called AWS, and this is basically my project folder, and I would like to keep all my project files into this folder. So I would just paste all my here into this folder. So I know that all the files that I need for my AWS project for Raspberry Pi would be seen here. So once this is done, we go back to our AWS dashboard, and in the lower right, click on done. The thing is created here, and now we can go to security in the left pane, and under security, if you go to certificates, then you can see your certificate shows up here and it's active right now. And if you go to policies, you have this Raspberry policy. So basically the way this AWS IoT Core works is we create a certificate whenever we register a device, and the certificate that we have to attach to the thing and to the AWS policy. So we select the certificate here by checking this box, and in the top right corner there's this action button. So we click on this drop down and then click on attach thing, and then in a drop down we select the thing, and the thing name is Raspberry. So we select the thing that we want to attach to the certificates, and then say click on attach to thing. Then we select certificate again and go to actions again, then click on attach policy, and then in a drop down we select a policy that we created. It's a Raspberry policy, so we have to select the policy and then click on attach policy. Now what has happened basically is we have attached the certificate with our AWS thing and our AWS policy, that's basically Raspberry policy. Now as far as the registration process of Raspberry Pi in AWS IoT Core concern, it's done. So now we can go to our MQTT test client here. We have to write a Python program into Raspberry Pi so that we could able to send some data from our device to our AWS IoT Core, and then we would able to test this. So here I have given the link in the video description that you can download this code from this GitHub repository place, and then you have this code button here, green button, drop down. If you click, you can see download zip file, so you can easily download this Python code which I'm using for this project. So in the download I have the zip file. I would just extract this folder, and into this folder I have this python.py file and root.ca file. So I would cut this file. I would just go to my project folder, which is our AWS folder on a desktop, this both files, Python file and root.ca file, into my project directory. Now look at this, all the things you have to manage into your project folder. We have a private key, we have a public key, we have a certificate file, we have a root.ca file, and the Python which is an application program. So this Python code would be sending a data from Raspberry Pi to AWS IoT Core. So we will going to open this file. So just right click and say open with, I would say show more, and I would edit with Notepad++. And you can see here's the code. And this Python code, basically whenever we run this Python code, then it prints the message just awesome on the Raspberry Pi terminal, and then it prints this message hello from binary updates on device/data MQTT topic, and this happens every 5 seconds. So if we succeed to connect our Raspberry Pi to AWS IoT Core, then running this Python script would basically send this piece of data, this string hello from binary updates every 5th second to IoT Core, and this basically ensure the communication of a Raspberry Pi with AWS IoT Core is working fine, right? And then we will modify this code in order to read the button status. So when we press the button which is connected to GPIO 21 pin, it will send the button pressed message to AWS IoT Core. Okay, I hope you get my point. Now the way this Python script will before we run this Python script onto the Raspberry Pi, we have to make some changes, because how could our Raspberry Pi knows which AWS account and to whom exactly to send the data to? And that would be defined based on the certificates file, because when we register our device on AWS account, then we have a specific device specific certificate file, then we have a device specific key file, and we have given a specific server, AWS server. So what we need to do is we have to change and modify this certificate file name, then the private key file name, and then we have to change the name of the server. So we will go to our project folder. So here you see there's a certificate file. I would right click, show more, and I would select and copy the name of the file, go to my script, and here cert file is equals to, and here I would replace the certificate that belongs to my AWS account. Similarly, I would have to replace the private key file name. So I go back to my folder, and here's the private key file. So I'm going to copy the name of the private key file, and then I would go to my Python script, and key file is equals to dot slash, and then it's basically a path where this file is kept, and this file is kept into the AWS folder. So make sure you don't change anything, rather you should keep it same. Just change the name of the certificate file and the private key, and then you have to change your AWS account has a specific server URL, so REST API endpoint, and to get that we have to go to our AWS account. So this is our AWS account, and in the left pane we have the settings. So when we click on settings, it would take us to this page, and here we have the REST API endpoint. So either you can copy this entire URL, or you can click this square boxes and it will copy, and then come back to your AWS project and just remove the URL, change the server URL that belongs to your AWS account. Once this is done, then you can save the file, and now once this is done, then we would transfer this entire AWS folder, which is our project folder, to our Raspberry Pi, and then we will run this Python script and then send the message hello from binary updates to our AWS account from our Raspberry Pi. So before we do anything, we have to log into our Raspberry Pi. So let's open our Bitwise SSH client to log into Raspberry Pi. So just log into Raspberry Pi, except for the session, click on the new terminal, and this is our Raspberry Pi terminal. But before we do anything here on a terminal, we have to transfer this AWS folder from our desktop of a laptop to our Raspberry Pi. So click on new SFTP window, and then from the left side here we have this AWS folder on our desktop. We have to transfer to our Raspberry Pi's home directory. So I would just drag and drop it to the right side on the Raspberry Pi terminal, and maybe right now you can see the AWS folder is transferred, right? So I can close this and I would open my terminal, and once I open terminal, if I run ls command, now you see I have this AWS project folder. So I would say cd AWS and then ls, and now you see all the certificate files and python.py. So python.py, Python code, root CF file, and all other things are here. So I would have to, if I run the Python script straight away, then it would throw us an error. It is because our Raspberry Pi would be talking to AWS IoT Core using MQTT protocol, and that's why we have to install the MQTT library, which is a Paho-MQTT library on our Raspberry Pi. So we have to run command sudo pip install Paho-MQTT. So this basically install the MQTT library on our Raspberry Pi. So this is done. Now you can run clear command and just run python python.py, and now you see just awesome get printed every 5th second, and we get this message connected with result code 0. That means we have successfully connected our Raspberry Pi to our AWS IoT account. So I can just make it small a little bit. so it will be more visible. Okay, so it's working fine right now. We get just awesome. So we have to go to our AWS account here. In the left pane, we have to go to MQTT test device, and if we subscribe to a topic, MQTT topic device/data, okay, if we click on subscribe, we will see the message starts coming. You can see hello from binary updates, and every 5th second we start receiving a data here, right? So this is how the code is working fine. Rather, here is our code. I can stop. So far we know how to send a data from our Raspberry Pi, which is our IoT device, to AWS IoT Core. Now what if we want to get the data of Raspberry Pi from AWS IoT Core to our front-end client? And I'm talking about one of the front-end client called MQTTFx. So MQTTFx is an MQTT client which we will install. So let's search for SoftBlade. And this is the company softblade.de. They basically makes this MQTT client. So we have to download and install this. So click on downloads. And once we come to this page, then you can see download latest Windows 64 bits. I will click on it and it will start downloading. So it's start downloading. Now I would click on request license button here. As it takes some time to get downloaded the software, I have to fill the form and request the license. This will give us for 3 months access, and I think it just takes some time. It's still opening up. Okay, so here I would put my name. It's fine. Websites, 3-month trial, and I'm not robot, and click on send, and hopefully they will send me certificate. So I have to fill this form. The form has so many things, and I check my email right now. Okay, I got this Nico Blatterman, and this is the license file MQTTFx, and I think I have to download. Okay, this is the license file for trial, so I would just download this as well. So the setup is still downloading, so maybe it takes some time. So let's wait. So this MQTTFx is very sophisticated piece of software. You can use it with your AWS IoT Core. It just connects flawlessly with all the security and encryption. So I prefer this, but you can consider using any MQTT client that you like. This is a safe file. Now why the hell this is to keep, show more, keep anyway. I think this is the way to go. Now once I make download and I give all the permission to keep this downloaded MSI file, I would just click on open file. I can minimize everything so that we can just focus on installation of MQTTFx client. I give all the permissions and then say next. I accept the agreement and say next. I think this is a lot of pain just to install this MQTTFx client, right? And then click on finish, and once it is installed, then let's search for MQTTFx. So we got this under the apps, right? So click on it. It would open up the MQTTFx client. So look at this. It asks us enter the license key, and if you remember on our downloads we have this license file trial. So just right click and I would just open in Notepad++, and I would just select Control A, copy all the nonsense and close this, and I will paste the content of my license file here and say apply and OK. And I think now I got the MQTTFx layout. Now I would click on this gear icon here. Then the profile name I would write, let's say binary updates. Then the profile type, we don't have to change anything. The broker address, that's basically our AWS server's address, and that would be found under settings. So go to settings and copy this endpoint URL. Then we have to go back here to MQTTFx and paste the URL here. The broker address, this will be 8883 because MQTT port to connect Raspberry Pi to AWS IoT Core is a secure MQTT. It's a 8883. It's not 1883. It's 8883. It's a secure MQTT port. And then client ID, we can just click on generate button and it will generate randomly. The communication is a secure TLS communication, SSL TLS. So we have to select SSL or TLS option here, and then we have to check this box, enable SSL or TLS, and then we have a lot of different options. I think we don't care all those things. Rather, I think I would say trust all hostname, check this box, and then we have the CA file, client certificate file, client key file. So here goes our root CA file. Just click on this three dots here, and on our desktop we have this AWS project folder. Select this root CA file. This is our root CA file. So select the root CA file and click on open, because it's a CA file, and then click the next three dots, and then this is a certificate file. The next three dots, this is a private key file. So this is a private key file. Okay, and then client key password, it's not very important, so I just leave it blank. Then I check this box, PEM formatted, PEM checkbox, and then click on apply and say okay. And now click on this connect button, and if everything goes well, so go to setting again and check maybe this one. Okay, certificate files, and I would say apply and okay, and then click on connect, and now you see it turns green, right? So basically, remember, we forgot to check that box. And now I can just create a little space here, and I would just delete this earlier, whatever the topic is, published or subscribed. So I will go to subscribe, and I would subscribe to our MQTT topic. It's a device/data. So on this MQTT topic, our Raspberry Pi is sending data. That's why we have to subscribe this device/data topic. And you can see right now we don't have any message at all. And if we run our Python script, maybe then we will start receiving data. So let's say python python.py, and then you can see we start receiving data. Hello from binary updates, right? You see I started receiving data here. Look at this, the data start coming all the way from our AWS IoT Core to our Windows application, which is our MQTTFx, which is an MQTT client software. Now, if you want a Windows notification, on a top right corner, you can click on this gear icon and you can click this notification. And maybe every fifth of a second, you will start receiving a notification. Look at this, now the notification starts coming up, right? Look at this, device data. Hello from binary updates, in a lower right corner of my screen. Okay, so that's how it works. I could make it small side by side for you to see. If I keep it open like this, maybe it doesn't look better, it looks ugly, but now you can see the notification and the Python script is running. At the left side you see the just awesome is coming, and here the notification is coming parallelly. If I stop the code, okay, you see this notification stop coming, right? So the notification has stopped now. Now if you want to clear this all the jargon, then just move it a little bit. I want to show you the option here in the corner. So you can just click here and say clear message buffer, say okay. And now I can again make it small for you to see. Okay, and now I run my Python script again, and the moment I run my Python script, you will see the code starts running on Raspberry Pi, and the notification starts coming here on a Windows lower right corner, and the data starts streaming onto the MQTTFx, which is our front-end client.
In the next video, we will learn how to generate SNS notification. It's called simple notification service, used to generate an email notification and SMS notification. And also we will learn how to store the data into DynamoDB database, which is an AWS proprietary database. So we're looking forward to see you into the next video. I hope you have learned something from this video, and we'll see us into the next video lesson. Bye bye for now.